All right, problem 3. It says triangle ABC is similar to triangle XYZ with AD being the altitude of triangle ABC. We got to draw this picture to see what we're talking about. So we have, I'm just going to draw this. Here's triangle ABC. It's similar to XYZ, so I'm just going to say, okay, here's XYZ. It's maybe a little bigger, maybe smaller, I don't know. But I know A is corresponding to that X. YZ, so the Y is corresponding to the B. See, B and Y. C is going to correspond to Z, so C's here, so I'm going to put Z here. With A to D being the altitude, so you have this AD coming straight down. Here's D, there's the altitude, AD. And XN, so here's N right there, being the altitude of XYZ. AB is 8, so I have this side is 8, and it'll be similar to whatever that side right there is. AD is 10. A to D, that altitude is 10. BC, that distance all the way across, it says is 12. And it says YZ, Y to Z, the distance all the way across on this guy, is 10. So this actually triangle is a little smaller, but we know they're similar, no big deal. So it says, what is X to N? We're trying to find this missing length right here. Well, I'm simply going to set that corresponds to the 10, as this length across of 10 corresponds to the 12. So just set that up. Whatever variable you want to use here. I'm just going to use xn. I'm going to say, hey, xn corresponds to the 10 here, as this yz length, which is 10, corresponds to the CB length of 12. So I got 12 times the xn, 12 times this length we're looking for of xn, is equal to 10 times 10, 100. I simply divide by 12, divide by 12. I'm going to get xn's length is equal, well, 12 goes in there 8 times with 4 left over. I can see that. 4 twelfths is simply 1/3. So 8 1/3. This length of xn has to be 8 1/3. That's what the altitude of that triangle must be.